QR decomposition, classical method, question number 3. Construct a QR decomposition for the given matrix. Capital A is given. First column 1, 1, 1. Second column minus 1, 4, 4, minus 1. Third column 4, minus 2, 2, 0. So given is a 4 cross 3 matrix by Gram-Schmidt method. Solution. Let A is equal to W1, W2, W3. So here 3 columns. So you can write it in the form of Q into R. That is QR decomposition. You know capital Q is nothing but Q1, Q2, Q3 into capital R. Step 1. To find Q1, let V1 is equal to W1. First column of the given matrix 1, 1, 1, 1. So norm of V1 is equal to square root of 1 square plus 1 square plus 1 square plus 1 square. That is equal to square root of 1 plus 1 plus 1 plus 1. That is equal to square root of 4 is equal to 2. Q1 is equal to V1 by norm of V1. That is equal to 1 by norm of V1 into V1. That is equal to 1 by 2. Because norm of V1 is 2. So 1 by 2. 1, 1, 1. That is equal to 1 by 2, 1 by 2, 1 by 2, 1 by 2. Step 2. To find Q2, first you find V2. V2 is equal to W2 minus inner product of W2, V1 by norm of V1 square into V1. W2 second column of the given matrix minus 1, 4, 4, minus 1. Minus here inner product of W2, V1 is inner product of minus 1, 4, 4, minus 1, 1, 1, 1, 1 by norm of V1 square, that is 2 square, V1 1, 1, 1, 1. That is equal to minus 1, 4, 4, minus 1, minus. So removing the inner product, minus 1 into 1 is minus 1, 4 into 1 is 4, 4 into 1 is 4, minus 1 into 1 is minus 1 by 2 square is 4. Here 1, 1, 1. So that is equal to minus 1, 4, 4, minus 1, minus add here 8 minus 2 is 6 by 4 is nothing but 3 by 2, 1, 1, 1. So you are adding these two, minus 1, minus 3 by 2 of 1 is minus 5 by 2, 4 minus 3 by 2 of 1 is 5 by 2, 4 minus 3 by 2 of 1 is 5 by 2, minus 1 minus 3 by 2 of 1 is minus 5 by 2. Now norm of V2 is equal to square root of minus 5 by 2 whole square plus 5 by 2 square plus 5 by 2 square plus minus 5 by 2 whole square, that is equal to square root of. Here see the denominator 2 square, 2 square, 2 square, 2 square, so you can write it 4. Then the numerator minus 5 square is nothing but 5 square, 5 square, 5 square, minus 5 square is 5 square. So adding means you get square root of 100 by 4, that is equal to 10 by 2, that is equal to 5. Q2 is equal to V2 by norm of V2, that is equal to 1 by norm of V2 into V2, that is equal to 1 by norm of V2 is 5. So minus 5 by 2, 5 by 2, 5 by 2, minus 5 by 2. So multiplying these two, you get equal to minus 1 by 2, 1 by 2, 1 by 2, minus 1 by 2. Step 3. To find Q3. First you find V3. V3 is equal to W3 minus inner product of W3, V1 by norm of V1 square into V1 minus inner product of W3, V2 by norm of V2 square into V2. So that is equal to W3 third column of the given matrix 4 minus 2, 2, 0 minus inner product of W3, V1 by norm of V1 square into V1 minus W3, V2 inner product by norm of V2 square into V2. So that is equal to 4 minus 2, 2, 0 minus removing the inner product 4 into 1 is 4 minus 2 into 1 is minus 2 plus 2 into 1 is 2, 0 into 1 is 0 by 2 square is 4, then 1, 1, 1, 1 minus here 4 into minus 3 by 2 is minus 10, minus 2 into 5 by 2 is minus 5, 2 into 5 by 2 is 5 plus 0 into something is 0 by 5 square is 25 minus 5 by 2, 5 by 2, 5 by 2 minus 5 by 2. That is equal to 4 minus 2, 2, 0 minus see here minus 2 plus 2 cancelled. You get 4 by 4 is 1. So there is 1, 1, 1, 1 plus minus of this one is you get 2 by 5. So minus 5 by 2, 5 by 2, 5 by 2 minus 5 by 2. That is equal to add these three by using your calculator. You get 2 minus 2, 2 minus 2. Norm of V3 is equal to square root of 2 square minus 2 whole square plus 2 square plus minus 2 square, that is equal to square root of 4 plus 4 plus 4 plus 4, that is equal to square root of 16 is equal to 4. Q3 is equal to V3 by norm of V3, that is equal to 1 by norm of V3 into V3, that is equal to 1 by 4, 2 minus 2, 2 minus 2, that is equal to 1 by 2 minus 1 by 2, 1 by 2 minus 1 by 2. Now Q is equal to Q1, Q2, Q3. Q1, write it here, Q2, Q3. So capital R is equal to Q transpose into A is equal to Q transpose. Change rows into columns or columns into rows into capital A given. Multiply these two matrices. First row, first column, first row, second column, first row, third column, second row, first column, second row, second column, second row, third column, third row, first column, third row, second column, third row, third column. That is equal to, here adding means you get 2, 3, 2, 0, 5 minus 2, 0, 0, 4. Therefore, capital A is equal to Q into R. Q you know already, write Q here. R is given here. So QR decomposition is over. So A matrix you are writing in the form of QR decomposition. Verification, Q into R. Q, R, multiply these two matrices. First row, first column, first row, second column, first row, third column, second row, first column, second row, second column, second row, third column, third row, first column, third row, second column, third row, third column, fourth row, first column, fourth row, second column, fourth row, third column. Adding means 1 plus 0 is 1. Then add like that, you get 1 minus 1, 4, 4, 1, 4 minus 2, 1, 4, 2, 1 minus 1, 0. This is nothing but capital A. Hence the proof. Thank you.